So where did we leave off? We had a way to have a child view update the state of a parent view. And we'll see this everywhere in SwiftUI. So child view somehow has to update a parent view. Bindings are one way to do that. But as you pointed out, there are some limitations to this. If we want to pass some state down 15 subviews in, this is not a very good way to do it. So we'll see some other things a little bit later that allow us to do that. But for now, the apps that we're going to be building in the next couple of weeks, this is enough. All right. So next, let's take a look at our. Where's my iPad? Let's take a look at our iPad again. So next thing we wanted to do is have a button. Well, so I guess first of all we can hard code a tip amount in there. So let's have tip. Let's have it be a double, and then the easiest way to represent percentages, in my opinion, is just to use the percentage divided by 100, so 0.2 as 20%. I think there's actually it's not called a percentage at this point. Maybe one of you guys knows. It's has a different name when you're not multiplying by the 100. But yeah, so let's set the tip amount. Oh yeah, let's set the tip to 20%, and let's see if we can add a button that will calculate our tip by taking whatever is inside our meal amount and then displaying it in our total tip label here that we have co-opted right now for just displaying the amount. So let's add that button first. So I'll go up here again. I could also type button, but let's drag that here. Oh, there we go. We have a button, and we'll just say calculate. And what are we trying to do here? So we have the user typing in the meal amount. We now want to do some math with this. So we have to take the meal amount, multiply it by the tip here, and then display it to our output label here. Actually, I think we had that. Should have that on the other side. All right, so let's see. Shouldn't be that difficult. Some foreshadowing here, because we're going to run into a very new concept as we're going here. Okay, so let's just try. So we have the meal amount. Someone is typing in something as the meal amount. Let's multiply that by the tip, and let's maybe for now just store that as a calculated tip. Okay, so we have some compiler errors. What is going on? And so here we don't need the canvas for a while. Let's just turn that off. We'll read this in a second here, but what's going on? Why do we have a compiler error? We are trying to multiply the meal amount by the tip. What's going on? Why can't we compile this? Yes? Meal amount is a string. Okay. So what can we do? Let's see if we can turn that string into, well, we have a double. So let's turn that into a double. Doubles have a nice initializer that take strings. Very nice. And let's see what happens now. Let's see if we can compile that. Oh, okay. So, first of all, maybe let's go back real quick. So what was the compile time error we had before? Binary operator multiply cannot be applied to operands of type string and double. So you very correctly pointed that out. Let's see what this changes to now. value of optional type double question mark must be unwrapped to a value of type double. So that might sound like absolute incomprehensible word salad to you, but it is somehow related to the error that we had just gotten. So somehow these are incompatible types. So somehow the tip double here is incompatible with the double that we get when we pass in a string into that initializer. So somehow they're incompatible. Let's see if we can kind of figure out what is going on here. So if any ideas so far? Any? Yeah.
So that it's not guaranteed that the amount is actual feature, so some other value.
Very good. Yeah. So what happens? So we've done it all evening. What should this mean as a double? In some languages, you will get something that will be garbage. So you might get -1 because it can't be converted. Very frustrating, because then you might be doing some math with -1, and maybe you end up with a tip amount of -0.2 or something like that. I don't know. What else could happen? So if you type in something that cannot be converted into a double, what else might a language decide to do? So if it can't be converted, what have you seen elsewhere? Exception, yeah. So, and exceptions, so maybe some languages will, so yeah, maybe some languages might force you to catch them, some might not. So if an exception is not caught and someone types this in, what happens to your app? Crashes. So what kind of an error is that? So we have runtime errors. Oh, sorry, we have runtime errors and we have compile time errors. A crash is a so yeah, between the two, a runtime error or a compile time error. Yeah, I think you're overthinking it. So we, at compile time we can have an error, or at runtime.
This is compile time.
So what we have here is compile time. If the app, if we have an exception that it does not get caught, what kind of an error is that? That one would be a runtime error. So which ones do we like better? Do we like compile time errors? Why do we like compile time errors better? Yeah, so as we're trying to build it, we can't build it if it's wrong. So if we're going to make a mistake, it'd be nice to catch it before we send this to a user. So the compiler figured out, oh, you are doing something dangerous here. Unless you show me that you did your work here and you're not making a mistake, you need to show me that you didn't make a mistake, or I won't let you ship this, which might seem a little heavy-handed if you're coming from JavaScript or other non-type safe languages, but it's really useful in writing code that does not crash or doesn't have unexpected behaviors. So this is one of my favorite, or this is one reason why I really enjoy writing apps in Swift. It just helps me not make mistakes, which I would do plenty for otherwise. Okay, so as you said, we should probably check this, since there could be an issue here. And the compiler figured out that we did something wrong here. All right, so what's going on here? So I brought some props. So we have a 3-year-old son. These are his bath toys. So I have to return these. So we have some numbers and some letters. I have some cups and some tape and some post-it note. What are these called? Index cards. Very good. Thank you. All right. So if I do the following here, so let's bring maybe up not simulator. I want the file new playground. And then, so yeah, what I like to do with the playgrounds, I said that before, switch it to macOS. It just builds a little bit faster. The initial, the first time. Okay. All right, so we have value A maybe. And let's say value A is 9.0. And then we have value, what do I have? So I guess this might be 9. No, yeah, I guess could be 9. And then I have a 1 here as well. All right. So what type is value A? So this might sound like I'm going to ask very stupid questions here for the next couple of minutes. They're going to sound very obvious, and then at some point they become maybe a little bit less obvious. So what type is value A? Double. Okay. So how does the compiler know this? We put a double here. If we did this, the compiler wouldn't know that we're talking about a double. So let's see what we actually get here. So value A, if I option, so command clicking goes to where something is defined. Option will give me more information. So if I hover over it and click, it'll give me more information about the thing that I have there. So actually value A was an integer. So if I don't have the 0.0, it thinks it's an integer. Now it thinks it's a double. So the compiler deciding that this is a double is called type inference. So we have something that can that the compiler can figure out what the type is, so it infers the type of the value that we have here. So we can have the compiler infer the type, or we can also be explicit about the type and just say this is a double. And then now if we did something like this, where we don't have the .0 afterwards, we still end up with a double here. So now the compiler does it the other way around. We're saying we want a double. This is a valid double. It just doesn't have the .0. So it'll turn that into a double, which is nice. But we wouldn't be able to put, so let's say we have an integer here, int value, and then we'll be explicit about that. Int, maybe 8. So if we try to assign int value to our double, that doesn't work anymore. So cannot convert value of type int to specified type double. Again, the same compiler error we got here. So we're onto something here. And then again, just to prove that the compiler, once it decides this is an integer, will complain. So this is an integer, even though I didn't say it was an integer, because the compiler thinks an 8 without a decimal place is an integer. All right, so we have two values here, value A and value B. They're both doubles. What's value B? What's that type? Again, stupid questions on my end. Please humor me. What is the type of value B? Double. Very good. Thank you. Okay, so we have 9. There we go. I'm getting confused with, here we go, 9 and 1. So we have 9 and 1. If we want to multiply them, can anything go wrong here? Multiplying 9 and 1? Okay, so that seems to work. We have 9 and 1. Let's see if that works. Value A times value B. What is the type of result 1 that we have here? Double. So if we have two doubles, we're multiplying them, we get a double. Okay. All right. So the concept that, or the mechanism in which the compiler will help us figuring out that we've made a mistake is, in my opinion, very clever. so we don't really have the concept yet that so if we have 9 here, if I want to save nothing in our value a constant here, if I want to save nothing in there, not nil, but nothing. So maybe we couldn't do something, or it hasn't been defined. How would we do that? So with just a double, I think I've heard you say not a number, or maybe we could have infinity, but that's slightly different from nothing. Like nothing means like maybe we didn't initialize it, or I guess not a number could mean that that we made a mistake somewhere, but then the compiler wouldn't be able to help us if the result is not a number. We would have to check. The compiler wouldn't be able to help us with that. So what the what the compiler does is, whenever there's something unsafe, it'll give us a little container, and it'll say this might contain a double. So there's maybe I'm missing an E. There is maybe a double here. But I don't know. So we're putting a question mark there. So let's label this container with. So we have this container here. This might contain a double. So if this was opaque, maybe we haven't checked yet. We don't know. So there might be something in here that is a double or not. We'll have to check. We have to look inside. So it's opaque, so we can actually see what's inside. Okay, so we have this. So let's say we have our meal amount. Oh. And we have double, and then we have a string that goes in there, and maybe we have a string that says 100. So this is where we had that issue, right? Where we had the meal amount that took a string in, but then we didn't quite know, like the compiler was saying, hey, you need to do some due diligence here. So we don't know if this is actually a double. So what the compiler does is, with stuff like this, so if we inspect with option, we have meal amount double question mark. So we're getting a container back. So this initializer, the double that takes a string, doesn't give us just the value 100. It doesn't just give us a number. Instead, it gives us a container. And so if we haven't checked yet, it's opaque. We don't know what's in there. And then it might have put a value in there or not. But to do math with it, we have to like unwrap this. We have to check what's inside. So let's maybe, yeah, I'll make it opaque. So I don't know, did I put it in or not? We don't know. So if I try to multiply container with we don't know what's in it with 1, so that's what the compiler is doing. Sorry, that's what the compiler is doing to us here, where we have maybe a double and a double. So it's not defined to do math with those two. So how do we check? How do we check? So if the compiler puts something in there, we'll look inside what's in there, and then to be able to do math with it. So this is just the container. It can contain nothing or a double. So we have to get rid of this container, take out whatever's in there. If we have a double, now we can do math. If nothing is in it, then we shouldn't continue to do the math. So the concept of these containers, where maybe there's something in it or not, maybe there's a double in it or not, they're called optionals. So we have a special kind of type that can hold nothing or a double. So those are optionals. And to do math with an optional double, we have to, it's called unwrap. We have to unwrap the optional which means taking out the double if there's one in there, or if we can't take something out, then not continuing. Yes, question?
Options are for everything, right? Like strings and
Yes, very good. So if we look at what this returns here, so again, I'm going to go to, I think this one will, oh, nope, not helpful. Okay, yeah, not a quick way for me to look that up right now, or to like demonstrate, but yeah, so there's doubles for everything. So if you create a type, you can turn that into a double, an optional your type. Any type can be an optional. So optionals, you can think of as little containers where you want to do something with it, but you have to check if there's something in there first. So you don't know, you have to check it first. So how do we check? This is so ingrained in the language, this checking if there's something inside a double or not, that we have some special syntax for that. That makes it really easy. So, so here we have maybe something in there. So, so this statement you can think of as truthy. So truthy means it can evaluate as successful. So there's something in here, then this I could think of this as success and true, or there's nothing in there, then that it could evaluate as false. So this is a truthy statement. There's something to it that kind of makes sense to look at as the outcome of this is true or false. So since it has this truthy nature to it, we can just treat it like a Boolean in Swift, which is very nice. So we can say if we can make this assignment and there's no issue with this, then we want to do our thing here. Or if that is not true, then we do something else. So let's play around with that for a second. So let's say if this is true, then I want the total, I want the result to be meal amount times our 0.2 tip. And else I want maybe I want to print something to the console, and we want to say not a number. Okay. Let me move this also. Yes.
So are all initializations treated as expressions, or is this just for?
You're saying so everything is an expression. Are you saying is every initialization a truthy initialization? Or could you put any initialization in here? Is that what you're asking?
Yeah, or is it just for? Like,
So it's just for this. So here we have, so this initialization here, or this assignment has something truthy to it. So it could fail because depending on the string that we put in here, it might not succeed. So the if let and then assignment is only available if we're dealing with optionals. So it's like a special syntax for dealing with these types of optionals. So let's play around with this for a second, and then maybe we'll see if that answers all your questions. Let's run this. Let's see what happens. And I guess so. The console is going to come up here in a second. So where there are values, we'll get them in the gutter as well. And that is taking a long time. Why is that taking a long time? Oh, here we go. So okay, so we have something in the gutter, and I guess we can print something out here too. So print the result is result. Okay, let's run that again. So we're printing out the result is 20 because we took, so we were able to take the string 100, 100 was, we were able to turn that into a double, and then we were able to multiply that by 0.2, so the result is 20. So let's see what happens if we add an A afterwards, and let's run this again. So 100A is not a number. So in this case, this assignment failed. So we weren't able to assign a double to meal amount. So we skipped this block of code and we executed the else. We don't have to have an else block. So if we remove this, we just won't get any output. So this was unsuccessful, nothing prints. This was successful, something prints. Okay, so let's see if any questions here. Let's see if let's see if where your understanding is with this. So here we have this meal amount assignment. I'm gonna comment this out for now to have the compiler not give anything away. What if in line, so I've done this whole thing here in lines 13 through 16. What if in line 19 I now want to double result? So maybe I want to say let result 2 equals not result, meal amount. I want to double meal amount. What are you guys' thoughts? So I'm unwrapping meal amount in line 13, and maybe let's have this be successful. And then in line 19, I'm trying to assign a new variable where I'm doubling meal amount. What are you guys' thoughts? So yeah, you're saying it'll double it and assign it to result 2. Is that what you're saying? Okay. Any other thoughts?
There might be issue because of the type, maybe.
Okay. So what is the type of meal amount?
As of now, it's double like the container, the half of an option.
So okay, so it might be an optional. Okay, so we have there might be a type mismatch because meal amount might be an optional. We have one thought that maybe this works correctly. Any other thoughts? Say it again. Does yeah, 100 in this case just stays the same. Yeah. Any other thoughts? So so neither of you. So no one has quite cracked it yet. So we're mostly there, but some of the reasoning is not quite there. So any other thoughts? Yes.
Because it will still run.
Okay.
Because at this point, meal amount has been, we've checked it.
Yeah. Okay. Yeah. Any other thoughts? All right. I think at this point we should just then uncomment this and see what the compiler tells us. Or if there's if we can run it. Let's see if we can run it. Okay. So cannot find meal amount in scope. Any thoughts about that? What does scope mean? Does anyone remember what scope means? Yes.
So like basically, like if there's an if block,
Yes.
and anything declared inside it, that would be its scope, and it can't go outside of that scope.
Very good. Yes. So so you were very close that it wouldn't run. But so we have meal amount. If this assignment succeeds, we're not dealing with an optional anymore because we are doing some math with it here. So the type here is actually double. So this will return an optional double, but the assignment of this, if this is successful, would be a double. The problem is it's only defined for the duration of our if block. So if we're trying to access meal amount outside of this if block, we're outside of the scope of this assignment. So at this point, it is again unsafe. So first of all, this doesn't exist anymore, but since we're outside of this block, it would be unsafe again. Whatever we don't know exactly. But yeah, so in this case, we didn't actually. The assignment is over. We're outside of scope. Any questions here? Does that make sense? Okay, good. Yeah, so there is another way to write this that doesn't work in the playground as nicely, but I think you were saying there should be a way that we're saying, hey, we've checked this now, so from now on, let's just say that we've checked this and we want to deal with it as checked, and we don't want to have all of this happen inside this block. So there's a way to do that as well. We'll see that a little bit later. But the way that we've written it right now, meal amount is only defined for this if block here, and same here. So if we have an else block, so let's see what the compiler says here. So we're trying to access something that is inside the if, and we're accessing it inside the else. So it's not defined. It's not in scope. Okay, so we have something that is dangerous. The compiler says, hey, you're trying to convert a string into a double. I'm going to give you this cup here. You can put whatever you have in there. And then so from now on, if someone wants to do something with this dangerous thing that you did there, I'm going to require you to check inside and look what's inside. So I guess we haven't really talked about what is in here in this cup when there's nothing in there. So we would say there's nil in there. So NIL, nil. There's not the concept of nothing in the concept of a Boolean or of an optional is nil. So if there's nil in it, the assignment failed. Any questions? Yeah.
Isn't that like no safety? Like
So we can have nil, but so nil in itself is not unsafe, but doing things to nil that were intended to be done to other things is unsafe. So it's perfectly fine to say, hey, this resulted in nil. As long as you're not doing math with that, that's fine. There's no safety, yes. So there's we have to check. We have to check that we don't have nil. Does that answer your question?
Yeah, so you can still have nil.
You-
You can still use it somewhere.
You can have nil, yes. You can pass nil around, but you're not allowed to do math with nil. So that's the forbidden thing. So we have to. The compiler says, hey, so nil and double are not the same type. So we can't do math with nil and double. Nil can exist nil can only exist when you have an optional. So it can be the nothing part of an optional. Otherwise, nil cannot exist. That's correct. Very good question. Okay, so now we are maybe able to do a little bit more here. So we're doing something dangerous. So let's only do the dangerous thing. So here, let's say maybe meal value instead of meal amount. So what type is meal value in this case? Optional double. Very good. So how do we unwrap? So that's the terminology here. We are unwrapping the optional. How do we unwrap it? I'm hearing it. Yeah, if. Okay. So then inside this if block, we can do things with it if it was successful. So let's say total meal value times tip. Okay, so see no compiler errors. Nope, very good. And then else, now we can do something when it's not successful. So if it's not successful, maybe here we'll add a little to do. Let user know that they gave not a number. Okay. All right, so we have our total. So right now we only have a way for the user to enter a meal amount, and we want to be able to show this total to the user somehow. So we want to update this text field. So we need another property here, and this might be total tip. What should be the type be for total tip? Double, okay. And so then, so yeah, I guess so we have to initialize this. So in this case, I guess we would have to give a default value. So we'll just give a default value of 0, and then so instead of assigning it to total, we can just assign it to total tip, and then here we can update total tip, and our text field will update it. Will show it. Our text. All right, let's see what happens. Okay, so we have a little bit of a formatting issue. We'll address that in a second. So let's type in something. Let's type in 100. Let's hit calculate, and it gave us 20, which is very nice. So let's type in something that cannot be converted. And so we don't have a nice way for showing that yet, but so maybe we can change something here in a second to make that a little bit easier. But yeah, so at least this didn't crash. So it didn't crash the app. We could go back to 100. Hit I guess maybe let's do something else. 1,000, 200. So our app did not crash. Okay, so yeah, maybe how could we make it so that we can also show a failure case and the total tip? So maybe our total tip here, maybe we could just format that as so this could maybe be a string, and maybe we won't call it total tip, but maybe we'll call it output or result, or maybe output, and then we can update the output in the else case with not a number, and then here we can now maybe we'll actually do this. Okay, so what did I change? Instead of having the number, the calculated number, we're just updating an output string. So that is a little bit easier to display in this text, where we might have not a number displayed or the total tip. So let's see what that does. Okay, so let's add something that we can't convert. Calculate, not a number, very good. And then let's do 100 again, and we have our total of 20. Okay, any questions here? Cool. So we have what? So I guess that, yeah, go ahead.
How do we fix the formatting in it? Like the two, like multiple zeros after the person?
So I think it did some inferring here, but so it's still for like a dollar amount, it's still not quite correct, right? So there's still we would expect 2, right? So I think it just the way, I'm not sure why it's now showing 1 decimal place and not 50. Not sure what is going on there, but yeah. So let's maybe change that next. So let's do that. So there's an old way and a new way. I will show you both. So the old way, that is a little bit more clunky. I will need notes for that one again, I think. Yeah, there we go. Okay. All right. So let's think about our app and who might use it. So tipping is a very American thing. It's very much ingrained in the culture because we're not paying the wait staff enough money to survive. So they're reliant on the graciousness of the patrons, which I find slightly troubling. But so there are other countries that maybe don't do that, but like there's still you might still tip. So tipping is not just only an American thing, but it might happen in other countries as well. So this app might be downloaded if you put this in the App Store. It might be downloaded by. So I'm originally from Germany. It might be downloaded by someone in Germany. How would that influence your? So here, how would that influence your decisions for how to write this UI? So how would we? So one, it might be nice to for the English or for the US users, it might be nice to show a $sign in front, so 100, so $20, great. In Germany, I would be using the euro, which has a different sign in front of it, or it's afterwards. So I might find this annoying if I download an app and it showed me the wrong currency. How would you approach this as you're writing an app? Is that something simple to solve or something difficult to solve? Simple. Okay. So now we add maybe this app can also be downloaded in China, and maybe we just enable all app stores that we can sell this in. Is that still simple, or what happened now? Yeah, so maybe we have to select a country first. So now let me throw another wrench in this here. So so this might look really weird to you. In Germany, this would be, and then I actually don't know. Oop, not good. Please stay. That's great.